Hi class, in this recording we're going to continue talking about Chapter 2 content from your A&P class. So as we look at energy, energy in our bodies is very important. It's the ability to do work. We can't do stuff unless we have energy. So work, when we think of work, I want you to think of moving something, doing something. And to do something we need energy. And there's different kinds of energy in our bodies. We can have kinetic energy, the energy of motion. Common examples that are used in introductory classes include water flowing through a jam, or the movement of a ball rolling down a hill. In our bodies, we have kinetic energy when we think of something moving from point A to point B in our bodies. For example, we can have the physical digestion process that depends upon some kinetic energy, or moving our body from point A to point B to go from a cold environment to a warm environment, we need to use kinetic energy. We also have potential energy. Potential energy in the context of A&P is going to be stored energy. It's not currently doing work. So going back to the dam example, it's water behind the dam. But in the human body, our potential energy is typically stored in the form of chemical energy. And that chemical energy is potential energy within chemical bonds of molecules that we're storing within our bodies. So as we look at chemical reactions can be defined as making or breaking a chemical bond. And chemical reactions typically are going to depend upon molecule A or chemical A and molecule B physically coming in contact with each other. So there needs to be some kind of a collision. They physically need to come in contact in order to make or break the bonds. And they need to come in contact and collide with enough force and with the correct orientation. So as we think of things we can do that increase the rate of chemical reaction, if we make a chemical more concentration or a reactant more concentrated, we are going to make it more likely. It's going to be more crowded, so they'll be more likely to have a collision. If we increase the temperature of the mixture or the reaction chamber, that increased temperature is going to cause the molecules to move faster, and that's going to cause them to collide with more force. And then finally, we can add a catalyst. And when we think of a catalyst, I want you to think of something that speeds up the rate of reaction, but is not used up in the reaction. In the human body, we have a lot of protein-based catalysts called enzymes. And enzymes will bind to a reactant and hold them in a specific orientation. And that specific orientation makes it more likely that the collision will have the correct orientation for the chemical bond to occur. A key thing we need to emphasize here is that catalysts are not changed by the reaction, and we can reuse them. We can repeat the process of catalyzing a reaction with the same catalyst over and over again. When we think of biomolecules or organic molecules, these biomolecules are bio-life molecules. So the molecules of life are biomolecules. And when we look at them, they're typically going to be organically based. These are typically going to be chemical compounds that contain carbon in them. And there are a couple exceptions, carbon dioxide, carbon monoxide. But for the most part, just think chemical compounds that contain carbon. And when we look at these biomolecules, we can break them up into four large categories: carbs, carbohydrates, lipids, proteins, and nucleic acids. So as we look at these biomolecules, many times they exist as individual subunits or large change. These biomolecules can be very large. Macro means big. And macromolecules are those very large organic molecules. They have ridiculously high molecular weights, up to 10,000 AMU, as opposed to single or double-digit AMUs for individual atoms. And when we make a polymer, we're going to have, as we look at this word polymer, I want you to think poly for many, and when you see this word mer, I want you to think subunits. So polymer means many subunits. So a polymer could be a macromolecule that has repetitive subunits, or monomers. Mono meaning one, mer meaning subunit. So as we think of starch, it is a common polymer, and it's made of many glucose monomers that repeat over and over again. This process of polymerization, or polymerization is when we take multiple monomers and join them together to make that larger polymer. And as we're joining these together, or taking them apart, we have two processes, hydrolysis and dehydration synthesis. When we think of hydrolysis, hydro refers to water, lysis refers to breaking down. So hydrolysis is going to be digestion. I think I skipped a slide here. Let me go back. Let's pause a second here. No, I didn't. I just have these two slides out of order. I apologize for that. So as we think of hydrolysis, it's water breaking down. So here we can have our molecule, our dimer, di meaning two, and if I add a water molecule, an H2O, that can use that water molecule to cleave the bond that holds the dimer together, giving us two separate molecules. So the water molecule during hydrolysis is going to ionize to make a hydroxide and a hydrogen, and the covalent bond linking those two, that links the two monomers together, is going to be broken. The hydroxide will be added to one of the monomers, and the hydrogen is going to be added to the other monomer. But I meant to cover dehydration synthesis first. So as we look at dehydration synthesis, sometimes referred to as a condensation reaction, this is going to be making a polymer. This is when we build up a molecule. So we can have monomer 1, monomer 2, and as we see down here, we have two hydrogens, one oxygen, and they can be combined to make a water molecule. And then we also are going to have a covalent bond right here linking the two monomers together. So during dehydration synthesis, we take smaller subunits, combine them together to make a larger molecule, and we also produce water as a waste product or a byproduct from this process. That's all we have for this recording. If you have any questions or comments, please feel free to post them on the class discussion board or shoot me an email. And as always, happy studies.